Hello everybody, and welcome back to my channel. What's up guys? In this video today we're gonna talk about RNP approaches on the Boeing 737NG. So first let's introduce what is the concept of RNP approach. So to talk a little bit widely about the RNP approaches, we can say that it is a new way of landing. Actually, it's not the landing itself, but it is a new way of approaching an airport to land under IFR condition. Till a few years ago, we needed an ILS or a VOR to land, depending on the weather condition that were at the airport where we intended to land. The only way that we could afford a landing in a marginal weather was using an ILS, so an instrument landing system, which is a ground dependent system, and the aircraft has only antennas to receive information from the ground, and that is the interaction between the aircraft and the ground transmitters that allows the plane to land. So for example, here we go with a practical example. I do not want to spend too much time in talking about ILS, because we all know, or at least we should know, what an ILS is. But for example, let me see. Yeah, this one, for example. We are talking about LA, the ILS runway 25 left in LA. Okay, so we have two antennas, one located at the opposite threshold, that is the localizer antenna, and one located abeam the touchdown point on the runway on one side of the runway. That's a glide slope, the one that gives the descent path. The signals of the two antennas combined gives the 3D path to be followed to land. And this, as I told before, is dependent on two antennas on the ground, and there are possibilities to land an aircraft with this instrumentation system with almost no visibility, with auto land and so on and so forth. And for example, here in Los Angeles we have a depiction also in from the top of the localizer beam, and we have a profile view of the glide slope beam. So in this case, Gianna is the final approach point, is where the glide slope is captured to start the descent. Usually this descent is 3 degrees. It is the standard descent. A few years ago, the world of aviation was not satisfied using only ILSs and VOR for the approaches, so they came out with a solution to use GPS or the PBN, the performance-based navigation of the aircraft, so the capabilities of the aircraft to follow a vertical and a lateral path in order to land an aircraft. So they came out with the RNAV RNP or GPS approaches. We will be talking today about the RNP approaches, and in the next video I will underline the differences between the RNP and the GPS approaches. To start with, I have found this from the FAA website. It's pretty clean and clear. So of course we are talking about RNAV and RNP. As it states here, required navigation performance is similar to area navigation RNAV, but RNP requires onboard navigation performance monitoring and alerting capabilities to ensure that the aircraft stays within a specific containment area. Of course, we want to be sure that the aircraft is not going outside from the intended path in such a critical phase of flight as, for example, the approach. There are several different levels of RNP. Examples of RNP levels used for approach include RNP 0.1, 0.3, 1.0, but there are also RNP 4.0 and RNP 10.0 levels that apply in the en route environment, of course. These three usually are the three different RNP levels to be found in approaches. A performance value of RNP 0.3, for example, assures that the aircraft has the capability of remaining within 0.3 of a nautical mile to the right or left side of the center line 95% of the time. So if we take this plate here of the Palm Spring approach in California, which is an RNAV RNP Yankee, for example, we have a specific path, a specific track, and the purpose of this, as in the minima states RNP 0.30, is that the aircraft will remain 95% of the time during the approach flown within 0.30 nautical miles from the center line to the left or to the right, for example. Of course, we can have different numbers here, but the basic principle is always the same. So we have a few things to think about before starting to fly an RNP. The first thing is my aircraft capable of flying it or not? This, of course, is depending on the aircraft type and the equipment that the aircraft has. We can say that in the simulator, mostly or almost 99.99% of the Boeing 737, for example, or Airbus 320 can fly an RNP. In real world, it's not only a matter of the aircraft you fly, but also the certification that the airline you fly for has. You can have, for example, a fully certified aircraft to fly RNP, but your company may not be certified for that. In that case, you just cannot fly, unfortunately, the RNP approaches. Then, of course, you need the procedures. So the airport where you are flying needs to have a specific procedure for the RNAV RNP, as this one, for example, in Palm Springs. In the USA, there are a few quite famous RNP procedure. One of them is, for example, in DC at Washington National. In Washington National, there is, for example, this RNAV GPS for a few runways. This is, for example, the RNAV GPS approach for runway 15, or this is the RNAV GPS approach for runway 33. Here we have the RNAV GPS approach for runway 1 and the RNAV GPS for runway 19. This procedure here says authorization required, for example. Authorization required is placed on all the procedure where the authority requires a higher level of certification to be flown. Usually, whenever a RNAV procedure has an authorization required on it, it's because the final track, the lateral track, differs more than 15 degrees from the runway center line, like in this case. For example, here the RNAV for runway 19 in Washington National is following the river. So to be able to follow the river, of course, the procedure needs to be full of turns. This is the RNP runway 27 in San Francisco, which of course has as well the authorization required because of the turn, and it goes down to a minima of RNP 0.30 or RNP 0.11. If we have a look at the same procedure but RNAV GPS for runway 27, we can see that this procedure can be flown to LNAV only minima or LP minima. What is the difference? The difference is more explicit in Europe, but I will start to talk about it right now from this example in the United States. When we are talking about LNAV minima, we need to use on board the LNAV and button on the autopilot, or a lateral navigation mode on the autopilot, to bring us on the correct track to be flown. When we are talking about LNAV VNAV minima or LP minima, we need to have a lateral guidance on the autopilot, but also a vertical guidance. So we need both LNAV and VNAV, for example. And as you can see, the LP minima is lower than the LNAV minima. As well as in Palm Springs, for example, in this RNAV RNP Yankee runway 31 left, we have RNP 0.30 and we have 734 feet as minima. So we need to have LNAV and VNAV, and our LNAV system needs to be capable of remaining in 0.3 nautical miles from the center line of the approach for 95% of the time. I can actually explain a little bit better this in Europe. Let's take, for example, Stockholm-Arlanda. Stockholm-Arlanda Airport has got quite a lot of different RNP procedure. For example, the RNP runway 01 left. This RNP 01 left is straight, so there is no authorization required on it, and can be flown to LNAV or LNAV VNAV minima. Of course, these are pan-ops and standard systems, so it's the European system and not the TERPS US system. But the principle behind it is just the same. So if we are using LNAV button only, we can descend to 550, and we need to add usually 50 feet to this, because LNAV only minima is considered to the approach, non-precision. So we cannot burst the minima. We need to start the go around at the minima, and we need not to go behind it. Then we have the lnap VNAV minima. This is considered as a 3D approach, as an ILS, for example. So we do not need to add anything to our minima, to our published minima. For example, for the Boeing 737-800, which is a Cat C aircraft, 420, and we can just put 420 on our primary flight display. Let's take another approach. One of these, for example, the RNP AR, so authorization required. Let's take the RNP AR Zulu for runway 01 right. As you can see, this approach has got quite a tight turn at quite low altitude between Sierra Alpha 551 and Sierra Alpha 638. So this as a authorization required because of this turn. So the authority, the Civil Aviation Authority, wants to certify that both pilots and the airline that are flying this approach are fully capable of doing it. And we have RNP 0.30. So we must fly this approach using LNAV and VNAV on our autopilot. We do not need any addition on the minima, so for example 509 can be reported directly into our minima window on the primary flight display. Then of course it is very important to pay attention to the limitation of speeds and altitudes, for example. So in the plane view, we can see that the Sierra Alpha 575 we need a minimum 180 knots. At Sierra Alpha 571 we need maximum 180 knots. Vertically we need to be at 4000 at RAMI, 2500 at 575, 2300 mandatory at 571, which is the final approach point, and then we have a 3 degrees descent with the arc to our minima, which would be, for example, 509. As you will see later on in flight, it is very important to have really clear in mind where the final approach point is. In this example, final approach point is at Sierra Alpha 571. This will be really important because we need to underline, meanwhile we are in flight, during the briefing, or even during we actually fly the approach, we need to have really clear in mind where the final approach point is. For an SOP thing, where the pilot monitoring needs to call approaching glide path, so approaching the point where we need to start our descent, and also to be able to configure our aircraft in due time for the approach. One last example I can give you is also in Europe, in Norway, Oslo. Oslo Airport, as well as quite a good number of RNP and RNP AR approaches. Let's take, for example, the RNP Whiskey, if I remember correctly. That's not the perfect one. Let's check the X-ray out. No, let's check the X-ray. I will be able to find it. Yeah, most probably. But as well, yeah, we have also LPV, as you can see, or LNAV VNAV and LNAV minima. But yeah, let's take RNP 001 left, RNP X-ray, RNP X-ray 19 left. Yeah, this is pretty curved as well, as you can see. This one as well is curved. This is pretty straight in, because it's an LPV, it's not an AR. But yeah, let's take for example the RNP Whiskey 01 right. As you can see, there is as well here authorization required, and few things. We also need to check out all the information we have on the plate. For example, in this case, the baro VNAV not authorized below -27 Celsius, and the vertical path angle exceeds 3.5 degrees above 50 degrees. This is because they are virtually built. Okay. And it's very important to underline as well that we need to temperature correct all the altitudes at the waypoints in order to be sure that the procedure is flown correctly on the vertical path. So we need to correct all the altitudes that are below the temperature corrected MSA whenever the outside air temperature at the destination airport is 0 degrees or below. I'm talking about Celsius temperatures. So without further ado, let's jump into the cockpit, let's jump into the aircraft, let's fly an RNP approach, and let's see how it looks like. Welcome to the cockpit, my friends. Here we are. At the moment the situation, the simulation is paused. We are in the air, cruising altitude. It's a quite low cruising altitude at the moment, about 25,000 feet, and the city of Palm Springs is exactly underneath us. If we jump into the cockpit, we see that we are approaching Palm Springs from the west, and what we are going to do in the meantime is prepare the aircraft for the approach. In this case, we're gonna fly the RNAV RNP Yankee runway 31 left in Palm Springs. This approach will be flown connecting the arrival Cloud 1 via the waypoint DCAS, yes, DCAS, into the approach. So just to have a good overview, I'm just popping out the tablet here and checking out the arrival for you guys. So yeah, a little bit bigger should be enough. So right now we are here approaching from the west. We are headed to DCAS. From here we are gonna turn back and join the arrival. This arrival that is called Cloud 1. So we're gonna fly DCAS, UBAPE, and then Cloud, and then to the thermal VOR. And here it says expect radar vectors to final approach course. So we have of course a holding available over Cloud if needed, but it's not the case. And after this we are going to fly this this approach here, the RNAV RNP Yankee runway 31 left. So this approach, and of course the purpose of this video, is to familiarize yourself with the RNP or RNAV approaches in the Boeing 737NG. So let's do a little briefing. Meanwhile, the simulation is paused and we are not losing any track miles for the briefing itself. So as all briefings start, we just begin from the beginning, as it says. So Palm Springs International, it's an RNAV RNP Yankee runway 31 left, plate 12-21, 10th of January 2020. And we have a couple of frequency here for the SoCal approach. Palm Springs Tower, it's a CTAF frequency if needed, and the ground, which is quite standard frequency for the US. And then the RNAV final approach course 309. As you can see, 309 has already been set on both course selectors in the 737. GSOP is our final approach point, and mandatory altitude is 2,900 feet. The minima for the RMP 0.30 is 734 baro, and the RMP 0.30 is the only one available for this approach and this airport. Aerodrome elevation is 477. MSA based on the threshold runway 31 left is 12.7. Then we have a few other items here. Authorization required. So it is an RMP AR, and of course it is specified in point number 2, RMP AR approach, and number 3 point says for uncompensated baro VNAV system, procedure not authorized below 2 degrees Celsius or above 54 degrees Celsius. The 737NG, at least the one I was flying, was not compensated, so we were unable to fly this procedure outside the temperature range specified in the plates. Then it says final approach course offset 1.10 degrees, pilot controlled lighting on 19.7, of course, if needed. So if you remember, we said that we were arriving via thermal VOR here, where also a holding is available if needed. Then our route will take us inbound TVUC point, and from TVUC to GSOP, and from GSOP to threshold runway 31 left. Vertically on the profile, we are gonna be at 4,000 by a TVUC, at 2,900 by GSOP, and this is our final approach point as we read in the briefing strip here. And then we're gonna descend on 3.10 degrees glide. Of course, will be a virtual glide down to the minima of 734. And 734 is already set here in my baro minima. Then we do not have any other consideration here. The visibility minima is 1 mile. That's the minimum visibility we need for this procedure. And for the missed approach, of course, climb 1800, then climbing right turn 4000 direct to thermal VOR and hold. Missed approach requires a minimum climb gradient of 340 feet per nautical miles until 3000 feet. But that's not a problem, at least with the 737. We have few notes around here. Procedure not authorized for airway on Palm Spring VR Airways radial 053 clockwise. That's not important for us. RMP 0.30 we know. Procedure not authorized for arrival on Thermal VR Airways. Okay, we know. No problem. Procedure not authorized Victor 64 westbound we know, and so nothing important on this for us. And then once we have landed, if we will land successfully, I hope so, we are going to vacate to the left side. As you can see, the runway is pretty long, is 10,000 feet, so it's more than 3,000 meters long. It has a displaced threshold, and then we just roll out, vacate to the left, most probably via Juliet or Kilo, and then taxi back to the terminal via Whiskey. So that's it for the briefing. I will just jump back to the arrival procedure cloud 1, and we will keep an eye on this chart from time to time during the approach, and then we will have a look at the next chart following the flight path. Okay, before we can start actually to fly the approach, there are a few things that we need to consider in our aircraft. Some things are 737 SOP, and some other things are RMP things. So for a better immersion in the flight, I will just unpause the sim and take it from there, going on towards the approach. Okay, so the sim is unpaused right now. Let me check if the sound is good, I think. So I hope you are able to hear me. I really hope so. Okay, I really hope so that you are able to hear me. So actually what we are going, actually let me do like that, so it will be a little bit easier for you all to hear me a little while. Okay, so I think now will be much better for everybody to hear me. Okay, we have unpaused the sim and we are 42 miles from Avery, and from Avery we are gonna fly what I said before. So Avery, DCAS, and then we join the Cloud 1 arrival into Palm Springs. Okay, so we have done the approach briefing on the plate. Now we need to put some items at the right place at the aircraft. So of course we're gonna select auto brake 2, even if auto brakes are not really needed for this approach, especially because it's nice weather and it is quite warm in Palm Springs at the moment. It is 28 degrees Celsius. We have 19 knots from 330 gusting at 28, clear sky and very good visibility. I will try to show you as well here the weather for you. Let's see if I can have it. No, unfortunately it says no weather information available. I don't know exactly why, but okay, that was not really nice from Avitab. Sorry for that, but the weather is as I just said. Then we need to plan few things into the FMC for the RMP approach. First thing that we can do from now, we go on to progress page, then we go into nav sorry my mistake, nav status, page 2, and we select VOR update off. Okay, this feature is not modeled here in the Zibo, but we should select it as off. This is mandatory for all RMP approaches down to LNAV, VNAV, LPV or RMP minima. And the other thing we have to do, but later on, is to correct our vertical deviation here, our vertical RMP in progress page number 4, to correct the vertical RMP from the standard value of 400 to the approach value of 125. But this must be done only after the 10,000 feet check. Otherwise it will give us an error on the vertical path. So we are approaching the top of descent. I will start descending according to the profile to 10,000 feet. And apart from that, we have done everything that we needed to do to perform this approach. Will be flaps 30 landing The wind is now blowing 19 knots, gusting 28, so I will add 10 knots on top of the vref. VNAV, we start to descend, retard, and VNAV path. Good. So from now on, our aircraft will follow the vertical navigation path. We have quite a strong tailwind at the moment, so most probably it will struggle a little bit to regain the vertical profile. It will try to regain the vertical profile trading the altitude for the speed, but it is regaining quite nicely without any problem. So we are approaching Avery, and from there DCAS and UBABE. To fly an RNP approach like this one, for example, we need and do not need few things. Let's see some of the most common questions that might arise during this kind of procedure, since many of you, especially in the flight sim world, are a little bit unused or not used to fly RNP approaches in the simulator especially. So what about the minima? Do we need to add a buffet margin on the minima, or we don't? Truth is that we need to apply additive on the minima only if we are flying a LNAV minima only procedure, so what is called a 2D procedure. If we are flying a 3D procedure, like in this case, we do not need to apply an additive. Okay? Next common question is how will the procedure will be flown? It will be flown using LNAV and VNAV. This might sound easy, but it is not. We need to check and be sure that our FMA, our flight mode annunciation on top of the primary flight display, will show certain specific information in order to be 100% sure that the aircraft will fly the procedure correctly. Otherwise, most probably, it might happen that the aircraft will not start to descend. It will stay stationary at the platform altitude without any descent. We will soon see what kind of information we need to cross-check here. So we said LNAV, VNAV, and then we need the speed intervention. So why speed intervention as well? We need it in order to manipulate manually the speed to ask the aircraft, the autopilot, to fly what we want to fly. Otherwise, programming the FMC with all the speed limitation would be too tricky or too hard to maintain in real life, because, you know, in real life you don't really know what the ATC is going to ask you to maintain as a speed restriction, for example. You can have a general guess, but not specific information. So being able to manipulate manually the speed with a speed intervention is much better. Then what about the altitude? Okay, we have steps on the descent according to the procedure. I'm bringing back the tablet once more. By now, as you can see, we have intercepted the arrival itself. So we have few steps to be maintained. So for example, if we look here at the profile, we will be flying with 4,000 feet on the MCP until T-book. Then I will set 2900 by GSOP. Then after GSOP, to permit our descent, I need to select the minima on the MCP altitude window. Of course, I cannot select the 734 feet on the MCP window, but I will select 800, the closest value that is above the minima that I can select on the MCP. Then what about when to select the missed approach altitude, which is 4,000, for example, in this case? Well, 300 feet above this altitude, so 300 feet above 800, so it's 1100. At 1100 feet I can select the missed approach altitude with an RNP flown with LNAV and VNAV. So let's see it specifically, one step after the other. So now we have almost reached 10,000. We have the altimeter setting 2981, and we are approaching a cloud, and then we will turn to the left towards thermal VOR, and at thermal the minima is 4,000. So actually I will already go down from now, since now, selecting 4,000 and allowing the aircraft to decelerate and follow the lateral profile. Good. Let's have a look on the outside. It's a very spectacular landscape in the meantime around here. We are in inland California and Palm Springs in this tight valley here. Actually, this procedure is not the most scenic we have in Palm Springs, but it's pretty interesting anyway. I think Palm Springs is a marvelous airport. is really nice. Is really interesting and challenging at the same time. So approaching 10,000, we have a seat belt on. A few lights are coming in as well. Good. If I can show you, this is the procedure that we are gonna fly right now. But if you look at if you look at this procedure here, you will see that is even more challenging. This is for the other runway. This is for runway 13 right, for example. But to practice RNP approaches in Palm Springs is just perfect. It's amazing. Good. Wind almost disappeared. As you can see, we do not need any backup from nav aids. We do not need any ILS frequency or any VOR. I have thermal VOR now set for just as a reference. I can set even Palm Springs 15.5 if I want, but it's not really mandatory, and there is no real need of it. So this is the real advantage of the RNP procedures. We just can fly an RMP procedure without any radio station on the ground. It's definitely really well self-contained. It's a good idea in this case, even if the weather is very nice, just to have the terrain mode on, to have a better look of what the situation is with the terrain around. As you can see, these mountains here are pretty high. They are up to 5,000 feet, even more. So it's a good idea to have a terrain on. So we are approaching thermal, and if we give a better look to the ND, we can see also the blue dashed line going to thermal VOR, because it's also a missile approach. It's part of the missile approach procedure. So we also have the dashed line with the holding depicted with the inbound course 310 and right turn. Okay, as you can see, the aircraft is slowing down by itself because it needs to be at 210 knots or below by thermal. This is specified in the plate here. 55 maximum, RMP 0.30, max 210. So now it's perfect timing to check here in the RMP, vertical RMP 125, and we select it here. So we have a vertical RMP 125. As you can see on the navigation display now, our vertical scale has become really narrow. Okay. In the meantime, we are turning, and we can further descend still to 4,000, so we're good to go. Very nice. So now look at the primary flight display. We have few items. RNAV 31 left Yankee procedure, and it matches what we have on the plate. It's an RNAV Yankee 31 left. Okay, 311 degrees. Okay, here it says 309. It is because 309 is the final approach course. Meanwhile, 311 is the runway course. Okay, and it was written here that the final approach course is offset. And then we have the distance. This distance is calculated by GPS. It's not radio calculated, okay? It's just the GPS distance. So the aircraft has done almost everything by itself, allowing us to be at a speed where we can configure and at an altitude which is good for the procedure. If we have a look now at the navigation display, we can see that I have highlighted the GSOP in the fixed page, and I have created a 2 nautical mile ring around it. This is because GSOP is our final approach point, so it's very important to have clear in mind when we have to start the descent. Oh, sorry. The aircraft was not that good enough, and the speed dropped below the up speed, so I will start to configure with flaps 1. We are approaching 4,000, and the next step will be 2,900 according to the chart. So flaps 2, it's a good idea to keep the speed low during RMP approaching, approaches, sorry, and I can select 2900. And it's now very important to check what we have on the FMA, LNAV, which is good. Green for the lateral and in white for the missed approach, and VNAV path. This is very important. We need to have a VNAV path in green here. If we would have had VNAV alt, the aircraft could not descend. So it's very important to check it out. Good. Let's continue to configure. Flaps 5. The runway is inside here. Good. Now we are approaching the glide path. So this is the call out, approaching glide path. So now it's time for gear down and flap 15. Speed brake are armed. And now it's also time to continue descent to the minima, so I will select 800 feet on the MCB, and the aircraft will continue the descent. Okay, radio altimeter is alive, and the altimeter is 2981. Time for the landing checklist to flaps. Cabin call is given, engine start switches are continuous, speed brake are armed, landing gear is down, standing by for flaps. So we go flaps 30. Quite gusty anyway. Even if I don't have any wind information from here, I don't know exactly why. But now we are fully configured, so we can close the landing checklist. So flaps 30 planned, sorry. It's 30 planned, 30 green light. And here we go. Short final on the RNP Yankee 31 left. So the mountains are pretty impressive all around, from left side, right side, and even in the navigation display we see a lot of terrain around. So yeah, now it's gusty. I can definitely see it on the airspeed tape. Perfect. And as we spoke, the runway is offset with our approach. So the runway is here and I'm approaching from here. So it looks like that I am almost aligned with this taxiway. As you can see, there is also a sign taxi, just not to mistake the taxiway with the runway. Quite gusty. 1000. Perfect. So now I can roll up to 4000 for the missed approach altitude on the MCP.
Approaching 31 left.
Okay, this is the RAS system going on. Soon I will have to take the aircraft manually to fly and land the aircraft itself. From now on, let's do it already. So disconnecting autopilot. On the 737, as you may know, the autopilot disconnection means also auto throttle disconnection. Let's see if I'm able to land in this condition, or if it will be a go around. Let's see. Quite gusty. Speed is good. Profile is good. Speed brake up. 2 reverses. 47%. It was a hard landing. Sorry for that. Man, you are braking. But we made it. We safely landed in Palm Springs, taking the next left. This is Juliet. Clean up the aircraft. Resetting the trim. Good. Speed brake in. And the after landing flow starts from here. Not to miss the turn. Oh, sorry, I just overshooted a little bit too much. I'm back on track. Back on track, back on track. And now we taxi to the ramp. Our landing report says that I have done a hard landing actually. It's 345 feet per minute, which is 1.53 G. I went above the threshold at 29 feet, which is slightly lower than normal. I touched down about 1,500 feet from the threshold, and I was just 3 feet left from the center line. Not bad with these parameters. 1.53 G is actually quite hard landing. But still, it might happen. It might happen even in everyday life, that especially in gusty condition like this, quite firm landing. So guys, meanwhile I am taxiing to the ramp. I hope you found this video useful and interesting. If you have any more question about the RNP or RNAV approaches, please subscribe to my channel, comment below, ask a question. I will certainly answer as soon as I can. I'm Flylure 737. Stay safe, stay healthy, and see ya.
We dance,